So today we're going to be going over the Android operating system. Uh, in case you couldn't tell, I'm a guest lecturer. Um, I am Manny's postdoc in his lab, and yeah, so we we chose to go with Android operating system. You'll see because it's a very open platform, and we use it a lot in a lot of our research projects. And how many of you have actually programmed in Android or iOS? Okay. How many of you know Java? Okay. It's not a big deal if you haven't done any of these, because I'm going to show you here in this lecture, kind of teaching you how to fish, because we obviously can't go over all of Android programming in one day. So I'm going to show you how to navigate the API. We're going to do a little demo at the end, and I realize that there's not a lot of outlets. So although I do want to do a demo with you guys, it'd be cool if you could program along. But if I don't know if you want to save it until the end, or because I know battery's a limitation here. Um, and we'll try to cruise through these slides. And if you guys need a break at some point, I'll stop and we'll go from there. Okay. All right. So in the last, it's only been a decade really where these mobile phone platforms have shown a lot of promise for across a lot of applications. They're everywhere. There was 2.6 billion in 2016, and 6.1 billion are projected by 2020. And they now have multiple processor cores, so they're very powerful. And there's multiple ways to communicate and interface with them. And you'll see what you could use touch, speech, or haptic feedback to interface with them. And then they also have a whole bunch of built-in sensors to communicate and interface with, to measure motion, orientation, environmental conditions. And so that's kind of the premise why we're introducing this in the context of embedded systems, because you guys are going to be doing a bunch of embedded systems projects in this course, and you have some state-of-the-art embedded systems in your pockets, with a whole suite of sensors that you can use. And then they also have a whole bunch of radios on them, not only for communication, but for sensing proximity and nearby objects. So, for example, the Google Nearby API doesn't need to be connected to the network to detect that, okay, there's a device right there. It actually uses some environmental noise that's around you. It actually generates some acoustic signals. And we could dive into that later if you'd like. And then, of course, you have the cameras that together with powerful CPU and GPU can provide you with an augmented reality. I mean, some of you might have heard of ARKit and all these new platforms that are enabled by these devices. And again, because we have this large suite of sensors, we can actually make a whole bunch of rich inferences from these. So, for example, from your location, you could make inferences about not only the location and places, but the religion, the friends and habitats, your shopping habits. There's no privacy nowadays. And even with acoustic, you could perform identity checks, speech, social context, your location type. And obviously with IMUs, you could do a whole bunch of, you could do human activity recognition. There's a lot of research in our lab that actually focuses on that. And you could even create passwords with your motion. There's a lot of research in that direction. You could do movement patterns. You detect aggressive driving, even your transportation modes, or some more health-oriented stuff like detecting epileptic seizures. And then, of course, you can also, these are easily interfaceable with other sensors. So if you have Bluetooth sensors, you could detect, these are some medical applications where you can connect them to medical devices, and they're currently being used for stress detection, to infer things about conversations or other medical conditions, as well as your smoking habits. And they have, as I mentioned, they have led to this ability to kind of monitor your physical and personal health. This is just one of several applications, or millions of applications that these phones are being used for. So, for example, on the right, there's this mHealth framework that's actually used today, where for healthcare innovation that allows patients to provide doctors with with their current healthcare status and with a whole suite of sensors that are enabled. And then also, AutoSense is used for measuring exposure to addictive substances that helps people get over addiction. That's why cocaine addiction was on the previous slide. And of course, there's a whole, in the research you can use these mobile phones for, performing some pretty. I mean, here where saying it's affordable way to do look at brains for medical diagnosis by enabling some lens-free microscopy or some lab on chip. We in my PhD we also use a lot of mobile sensors like this for some advanced application because it's if it's very affordable and it's very powerful. And then this is actually a project that we're working on now, where this is kind of a more realistic setting where we're actually enabling a whole suite of sensors on patients with brain implants, where we're trying to capture the human experience and see how it correlates to brain signals that are. So we have epileptic patients that have brain implants, and you're monitoring the hippocampal activity. And the goal is to see how brain encodes particular memories. So I won't get into some of the details about the neuroscience behind it, but in a nutshell, we're seeing, okay, if we could put them on this path and tell them to take a tour of UCLA, we're going to see how the brain signals correlate to some inferences that we're making across these sensors. And we have this large suite of sensors for this project, where we have all these devices that are kind of fine-grained, like a GoPro and some matrix this matrix creator that's kind of running on a Raspberry Pi, where you have all these directional microphones. But in addition, we also have a smartphone that's going to be hanging here, and the idea is that eventually this is something that these users will want to take home if we're trying to help them with the encoding process, because these implants can provide feedback to the brain as well. So in a nutshell, we're trying to see if we can make the same inferences using only the phone sensors, so that it's portable and they're not wearing this Ghostbuster setup, and it's very lightweight approach, and we could also maintain privacy, so we don't have to have a GoPro on them and all that. And this is actually an ongoing project, so for those of you who are still thinking about projects, it's probably something we're going to formalize in terms of what you can contribute if that's something you're interested in. And we also have other projects that are using these mobile phones for in this same context, we're still using just mobile phones to see how we could do localization of people. So when you're walking through buildings, for example, you can't use GPS to localize them. So we use other sensors such as the IMU or what Wi-Fi access point you're connected to try to localize yourself in this context and keep track of where you're going. And you can see how that's important when you're trying to infer, the human experience. And then, yes, this is just one more example I'll give where you can do this mobile collaborative computing. This was a project out of MIT where they essentially relied on these mobile phone networks to detect and track the state of traffic lights. I don't know how much I trust it, but it was a pretty cool project where they showed how they can make inferences using using the camera signal and all these other sensors of the car, and provide feedback to the control loop. But it's a cool proof of concept, but it's affordable way to help with providing a self-driving car solution and all that. So, and then finally, this is an area of interest for me, at least, where there's also the Android in the Internet of Things. So there's, in addition to the API for Android, if you know the Android API for mobile phones, it's very, very similar for the Internet of Things. So you could program a whole bunch of different devices. And I am personally interested in how we can expose certain services of these IoT edge devices to see what types of inferences they can provide us. I'm just, if you guys are thinking about projects, these are just things to keep in mind, different platforms you can use when you're trying to make some embedded system projects. We could do some cool stuff. We're going to throw a whole bunch of ideas at you, so stay tuned for that. Okay, we'll take a little bit of a deeper dive now into actual mobile platform. Yes, it was initially developed, a little bit of history, it was initially developed by Android and acquired by Google. And the OS was released in 2008, which seems like forever ago, but it was actually only 11 years. And okay, now this is outdated. It should be, we're now in version 10, not version 7. Sorry, I thought I had updated this slide. But it does support, Linux-based systems as well as ARM, MIPS, and x86, and now all the IoT devices that I mentioned. And it's open source under the Apache license, and more importantly, they're written in Java, which doesn't. I don't think you need to know Java for some of the for using the API. It's pretty straightforward. The Android Studio is pretty nice, and we'll get into that in a bit. But there's also, I don't know if any of you heard of Kotlin. I don't know how to pronounce it, but that's the other language that you can use to write Android apps in. And it's meant to be easily integrated with the Java virtual machine and all the compilers. You could in Android Studio, you'll see that you can convert Java code to Kotlin and vice versa. But today we're just going to focus on Java just for simplicity, so it's not confusing. But if you go to the Android API, you could see it everything, all the source code, all the reference documents you have a Java version and you have a Kotlin version. By the way, feel free. I know it's pretty high level now, but going forward, if you guys have any questions or anything, just let me know. And yeah, so this is the market share in 2018. Android made up 75% of devices. Even though everyone has an iPhone, people forget how many different distributors of Android there are, as well as internationally it's very widespread, and you also have much more affordable platforms on Android as well. So that's why it's so widespread. And so we'll go through actually some of the evolution of Android to kind of see how things got motivated. So, at 1.1 this was the first Google phone. I don't know if any of you had this or if you're too young, but yeah, so they opened source right after passing the first initial test. And so this Android came out around 2006, 2008, whereas the first iPhone was introduced in 2007. And yeah, it had a whole bunch of vulnerabilities. It was very unpolished. It was very, you could compare it to the iOS at the time. It was very clunky, and had a very limited set of features. And then in 2.x, they made the search more easy, and they put a lot of effort on the speech recognition. And so, I mean, early on, I remember it was pretty robust, and they had this just-in-time compilation technique that made apps perform 3 times faster. And then this they call this the version we don't not speak of, 3.x. It had a whole bunch of issues, and this is actually around the time when Apple introduced iPad, and it was really all about the tablet market at this point. So they had a whole bunch of Android tablet OSs that were pretty clunky. And then from 4.0 to 4.3, I mean, this was, I remember when I was doing my master's, this was a pretty robust platform, and a lot of research was done on these platforms. And they had support for LTE technology at this time. They redesigned the UI. It was much nicer than before. And this was right when the Apple iPhone 4S came out, and they had a stereoscopic 3D smartphone. And also Google Play services came out around this time, so you could download a whole bunch of apps in a unified way. And around 4.4, this was when the Nexus phones got really popular, and the Google Glass came out, and it supported some of these Android platforms. And then in 5, Lollipop, they had a lot of material design, and they had Android runtime, which was another 3 times performance gain. And then when Marshmallow came out, they had real-time permission checking. So a lot of security research at this time was, you provide you. I mean, we'll go over permissions in a bit, but you'd essentially provide you would give permission to any app, and it would have access to whatever permission you gave it for the rest of its life cycle. So this was when they first introduced, whenever permission was trying to be accessed to any sensor of your phone, like your internet or your location, it would ask you in real time. And yeah, and then in 7 they had the split screen functionality, and you can see, Pokemon Go came out around there, and they had these more granular permissions, where they were fine-grained permissions, and they redesigned the UI. And then Android 8, things started getting more interesting. This was as recent as 2017, where you had picture-in-picture, and they kind of focused on the execution limits of the background. But also 8.1 is where they started introducing the neural networks API. So that's when you could do some inferencing on the edge, and this is when the AI revolution really started taking off. And also the AR Core library came out around this time to do some augmented reality apps. And then the last couple of iterations, they have some minor UI updates where you had like some tap into gestures, and some smarter battery, and they had notch support for those phones that have the notches at the top, and they have it was called Pi, so because they had these slices and app actions. And Android 10 didn't have any fancy name, but they enabled dark mode, which is cool, and they had focus mode, which allowed you to kind of, if you wanted to focus. How many people have Android in here? Android phone. And are you guys up to date on these latest ones? Okay, cool. Yeah, and so then they overhauled the permission model. I was just briefly. I don't have an Android. I was briefly looking at this, but it essentially they completely changed the way that permissions are managed in the latest version. But more, I so I was I saw that Android 10. I was updating these slides before this, so I mean, I could give a better overview of the overhauled permission model if I had more time to look into it. But and when you deploy an app, there's a whole bunch of players in this ecosystem. You have the distributors, like the OEMs that are kind of developing all the hardware of these phones. You have Google, who's kind of collecting all this data and providing the OS and everything. Obviously, the consumers. Then you have the freelance developers that are developing third-party APIs, third-party apps, and then you have these monster app dev houses that are kind of dominating the market and purchasing a lot of the freelance apps that come out. And they describe this as an hour-style architecture, where at the top you have the application developers, and in the middle, so you have this open source project, which is the operating system that it's only maintained by one entity, and then the hardware developers are also very widespread. So that's why you have a large group of people at the top, a large group at the bottom, and a single entity in the middle. And this is a simplified overview of how the architecture looks like. So at the top you have the apps that you deploy, and then you have the application framework that enables the APIs that you use. So if you want to access any sensors, or even the basic classes that you override, this is enabled by the application framework. And then you have the Android system stack and the Linux kernel. And still simplified version, but a little bit more granular, is you have the application layer, the Android framework, system services, which we'll go into services in a bit, and then you have some Java core libraries that provide you with some core functionality that you'd use it when developing any other Java applications. And obviously they have the Kotlin version of it. And then here you have your Dalvik runtime and Android runtime. This is your virtual machine that runs all these devices, just like a Java virtual machine, for those of you familiar with Java at least. And then you have a whole bunch of others other systems. There's these toolbox, some native daemons, and native libraries that, and this hardware abstraction layer that interfaces with the Linux kernel. And so this is kind of the most recent set of releases. We kind of went over them, but you can kind of see the API levels. And it's important to note this because you'll look at the versions and you'll see later on that when you're developing apps, you'll have to specify the minimum requirement for a particular app. So if you want to say that, okay, I know that only certain functionalities are enabled at Marshmallow, then I want to say the minimum API level for this app and anyone loading this app is going to be API level 23. And that's something to keep in mind when you're doing these apps. And generally, a good model is to try to make your app as robust as possible, because if you're developing and you're trying to deploy this on the Google market, you want as many people to be able to download your app as possible. So, but it's a trade-off because there's also new APIs and new things available. The further up the ladder you get. I mean, it's annoying because you'll see that there's little minor updates across different APIs, and sometimes you're forced to jump to the next API. Even like I was just debugging something the other day where it was the media player where we're developing a playback for a video, and it was I think just to slow down the video programmatically. It was, I think, a jump of like 4 APIs, so I had to increase the API level by that. So it could be a nuisance sometimes. And then one of the biggest reasons, as I mentioned, why you want to support these minimum APIs, because first of all, not everyone stays up to date with their software. I'm sure several of you have been guilty of not updating your software, but also the ecosystem is fragmented in the sense that this is kind of hard to decode objectively, but the whole idea is that because it's an open source project, you have so many different vendors, and whenever they release a new API feature from the AOSP project, then it takes a lot of time to percolate throughout all the other developers. So this is kind of just showing you that as time evolves across different APIs, this shows the amount of platforms that supported them. So obviously this was 1.0, but as you can see, it kind of whenever the API is released or comes out, it starts from 100% support, and it just kind of fades. It kind of fades away. So in addition to people not updating their phones, you have the actual developers like Samsung or some of these other developers not updating their APIs, or just because they have to augment their custom systems. And so you can see here the difference. This is not an advertisement for Apple, by the way, but I feel like this presentation is coming off that way. But you can see that iOS, for example, this is the amount of people at the time when iOS 8 came out. It was supported by 85% of devices, whereas only 13% supported up to iOS 7, and then only 2% supported up to anything before that. And when 5.1 or Lollipop came out, only 2.6% of the devices supported it, and whereas there's the next biggest majority was 4.4, which is two versions before that, which was 39.3%. And then this is all the different Android screen sizes at the time. So you can imagine that not only when you're developing these these apps, you have to worry about, okay, how many phones will support this app, but also how is my app going to look on all these different devices. So these are a lot of design considerations that come into play when you're doing this app development. Yep.
In the previous plot, was the white line just the percentage of the maximum used
Yeah.
OS?
Yeah. I think it's just like an average. It's just like kind of going like the average supported devices. I think. Yeah. Laser. Yeah.
Do you guys use React Native at all? Because then it would work on iPhone and
So I've seen that. I've seen Corona SDK too. I mean, we personally I don't. But yeah, there are a lot of platforms where you can kind of develop it on. It's third-party platforms where you can have this general API, and then you could you could deploy it on both iOS and Android, and some of them are very powerful. But I will say, like, if Android comes out with a specific API, sometimes if you want to customize it to it, or if iOS has a specific feature, sometimes it's. But I think for general purpose applications that might not be that complex, yeah, that's most likely the way to go. Where you just have a third party app and you just deploy it right once, deploy everywhere else. So this is the Android application frame. So we're going to kind of go through some of these components, starting from the Android application framework, and in particular, we'll talk today about activities, services, content provider, and broadcast receivers. So Android activity is kind of the main component of your applications, where it's an activity. It's a single focus thing that a user can do corresponding to one UI screen. And so when you start an app, it will typically have a main activity where it will call a main activity, and it's essentially your entry class, your main function. And in this lifetime, it's going to start on onCreate and end on onDestroy. So every time you open an activity or call this activity, then it will call this onCreate function. It's kind of what happens at the beginning, and then whenever you stop the app, or so that's whenever you close it or anything like that, Android will always call the on stop. And the only time that it will ever not call on stop is if your app crashes, if you have if you reference a null pointer or something like that. And then there's a visible lifetime, where it's actually from the visible lifetimes from sorry, I said on create to on destroy. There's also on start to on stop. So on destroy is actually when you close that, when you kind of stop your app altogether, whereas on stop is when you kind of navigate away from it. And then the foreground is on resume to paused. So that's when it's partially visible. So it won't delete. It won't kill the app altogether, but you could still resume it. So this is kind of this state machine where you define different functions whenever you want something to happen. And a lot of times, it, it it happens because if you navigate away from an app, you might want to stop writing to a file. You might want to make sure that your any files are stored or saved. Uh, it's just a way of safely navigating to and from these different components of your app. And this is a brief skeleton of the activity, and you can see, you have a declaration of the package that you're using, and we'll get into packages in a bit. Normally, this is auto-generated, but you could think of packages as kind of a file structure. And import is just like in Java. You would have to import different Android classes, and then you have this public class myActivity extends activity, and this is actually it's not activity anymore. It's, I think by default it's app. I forget the name of it. It's app compat activity or something like. It's a implementation of activity, but it's the same concept. And the whole point is that you extend the base activity class that kind of defines some of the it's an interface class that defines what needs to be implemented. And for your app, the base class, the base function that you need to implement is your onCreate. You need to tell it, okay, when I get an onCreate, what do I do? Um, because by default it'll just destroy everything. It'll delete all your resources and all that. So this is called normally. Actually, nowadays you have to call override. So here you could, I mean, it's just like in Java where you can either call public void onCreate and you're overriding this function, and you call super.onCreate. I think by default now it actually does this automatically, but it's the whole point is that you're calling the superclass to do the generic work for parent activity class, and then this is kind of the stuff that when you create a new file, it will when you create a new project and it will generate the main activity and everything, and then you'll call. This is kind of the main point is uh, you'll get set content view, and it kind of tells you what is the XML file associated with with my with my main class. And I could show you very briefly if we go, let me exit this. I could show you in Android Studio. Let me open a new project. So if you open a new project, now it's pretty nice. You could say basic activity, empty activity. Generally, I like to do empty activity because all these other ones might add some functionality, but they all have their benefits. But when you generate an empty activity, then you could call it my application. We could say, okay, test application, and you could specify the minimum API level, like I mentioned. Everyone see that okay? Is it too small or anything? And then the language, I'm choosing Java, but you could put Kotlin if you want. If you want to get brave and play around with a new language, that's your choice. And then we finish, and now I have my new test application. So you're gonna have this file structure. So I remember I mentioned that your package is essentially kind of like a declaration of your files, of where this resides in your file structure. So so this main activity here is automatically generated, and it's in com.nestle.testApplication. I can't spell right, so it's actually something else. So yeah, by default, it generated all those three main functions. It generated this onCreate because it's required, and we're overriding it because we're overriding the parent activity class, and we're calling the super onCreate to kind of handle all the basic all the default activities, and then it's setting the content view. Let me see how I'm doing on time. So for the main content view, you actually have. We'll go into these in a bit, but you have your Java classes and you have your resources in the res folder, and I'm not going to go through what all these mean because typically what we'll focus on for today is the layout. And layout has all your XML files for your different activities. And you'll see later people use values for strings, color definitions, and styles. All these have their own functions, but we'll focus just on the layout for today. And the layout view is actually pretty nice. So here you can see there's a design, and so the design actually doesn't show anything because it's small, but you could see here there should be a hello world, I think, if I could get it to show nicely. Yeah, so by default it generates a hello world, and this is what's called the text view. It's just like a little text box that you could generate, and this is a relative layout, I believe. So we'll get into different types of layouts actually. So here's the XML layout. We define this text view, and don't worry about remembering all this because we're going to go into each component individually, but then I could essentially build it. I can make my project, and I have this little, so it's just building right now, and you can see the output here. So it builds correctly, and then I could run the app, and I'll show you. I'm actually connected to this tablet here. So this is the tablet, and okay, it shows hello world. So actually, so I'm using I'm using this new app called Visor. It's just showing what's going on my on this tablet here, but there might be an ad every so often, so I didn't buy the premium version, but you just have to deal with that. So yeah, I mean, that's generally. I'm going to show you some components for the rest of the class. We'll go through some of these programming environments. So yeah, that's an activity. I mean, everything clear so far? Pretty straightforward. Yeah, so it's the Android Studio makes it pretty easy to interface with all these devices, and I think it's fairly simple to get into the API because the Studio it makes things very easy, and it tells you what you're doing wrong, and it tells you. We'll get into the build scripts and all that later, but it's really nice. And later on, I'll show you because the emphasis should be kind of how we interface with those sensors. So we'll get into the sensor API in a bit. But yeah, as I mentioned, views are essentially the GUI controls. So I showed you a text view before, but we could also have an edit button, edit view, or a button. So if I go back to, I'll show you an example in a bit. But if you have an activity window, typically consists of views and view groups. So you could have, for example, lists, or it's hierarchical, where you could have a layout where you can have nested environments. So for those of you who have done GUI development, it's just like any other GUI development. And you could do. They could also be set either statically, where you can use that little editor, or you could programmatically generate views or add to your GUI. You could generate buttons. You could set different properties. You could set the focus. So if you have like a little text edit box, you could put the focus on there so that they could start typing. You could have an event listener. So the most common event listener use is when I click a button, and we'll get into event listeners in a bit. And then you could also set the visibility. And then we could use, as I mentioned, you can use the layout to place views. This is where it kind of gets hierarchical. So if I kind of go here and I show you, I could add a button to the front here. I don't know if there's a way to zoom in on this, but let me see if I could make it larger. Yeah. So I just dragged the button. If you want, you could also, do this programmatically. It automatically generated the XML code, and you could figure out the layout and the width and all that. But I mean, yeah, some people are very particular, and when you get, it's kind of it is an art. So it's just like any other GUI development. But some of these are just kind of nicer. And this is a constraint layout, but there's a whole bunch of different types of layouts that you can do. Like linear layout is essentially just drag and dropping it, and then it will kind of keep everything flushed together, and you could add space if you want. We don't have time to get into all the layouts. And then here, you could go here and say, okay, I have a button, and let's say I wanted to call this test button, and you could then say, let's say I can then do button B. So I'm going to do button B is equal to find. So we're going to import button. There's like a little shortcut you can use. That's, I think, Option Enter, and it automatically imports your button, just like any other Android. And we're going to try to grab that button by doing find view by ID. So find view by ID is going to be your best friend when looking for different views. And there's the general resource container or class is called R, and then you'll say R dot, I think it's uh, layout dot, I think it's r.id, sorry, and then it should be test button. So r.id is kind of accessing all the IDs that you specified for all your views, and then there's test button. And to be honest, you're not gonna have to memorize all this. I think the key to the art of of, of programming in Android is just like any other Android. You're gonna be Googling how to do this every time. Probably going on Stack Overflow and saying, okay, how do I set an event listener for a button? That's the reality of this. There's no way you're gonna remember every single thing. Like right now, I don't remember the exact syntax for setting on-click listener, but so you could do that. You could say, okay, b dot set on-click listener, and then you could set on-click listener is essentially just going to tell you what happens when I click, and then there's different ways of kind of showing what happens. So there's different actions that you can do. You could either set kind of an anonymous function here where it says when I call this, for those, I don't know if you guys know anonymous functions. If you don't know Java, then you may not be aware of it, but it's just, you could either define a function here separately that says, okay, when I click it, call this function, or you could set it an anonymous function within this space. Just a lazier way of doing it. And then here, you could, let's say we want to change the text of that hello world. So we'll go to our activity main, and we'll look at hello world, and we go to the ID, which should be here. Okay, ID will be text view hello, and then here we can come back to our main activity and say text view. Actually, we could set this up here. View TV is equal to find view by ID r.id text view hello. So we're just grabbing that text view, and you're gonna have, for all the types of views, you're gonna have classes for them that implemented, and then you can say tv.set. There should be like some set text, and you can set it to some string, and you can say we changed it. So here, so that's just some Java we have to take care of because we're accessing it from an inner class here. We just have to put this final. It'll tell you. I mean, if I have this error, even if you're not familiar with Java, it'll tell you like, hey, you need to make this you need to declare this as final. So you could just do that. So again, Android Studio is very helpful. So you shouldn't be afraid of approaching it, even if you don't know Java. Although it is nice to know Java, so I'm not discouraging you from learning either. So now, if we run the app, let's see if my app actually works. It's just building. Okay, so the button kind of came out at the top left. Okay, so we changed it. It was a successful demo. All right, so that's just an example of how you can, add some new views and then set some event listeners. But we'll get to a little bit more detail on that. Everything clear so far? Any questions about anything? Or yep.
Just to make sure, how did you connect the Android phone to the IDE?
Oh yeah, so it should. So when you install, we'll get to the installation part in a minute, but so when you install Android Studio, it should automatically do that on certain platforms. So if you're on Mac and Linux, usually it automatically installs those platform development tools. But the way that it actually interfaces it is your the Android development tool set is a huge suite, and one of them is called ADB, Android Debug Bridge. So it's this binary that comes with the whole development environment, and it's how you kind of load it. And if you want to, if you want to program on the command line, you could use the debug bridge to load different APKs and install them on your phone. I like to use it sometimes, and it's nice to look at. I mean, a lot of us probably use the command line, so it's nice to look at the logs of the phone as well. So it's a very, very powerful tool that you'll probably use if you get into this. So that comes by default on Macs typically, um, at least when you're installing it. So you can then, for example, this is a very, very, very brief tutorial on ADB, but if I say, so ADB has it's a whole command line function, and if I say ADB devices, it actually shows the device. And to actually, I should also point out that in order to interface with your device, you're going to need to enable the debug options. So that was a very good question, because if you're trying to program all these phones have been messed with and are very old, and they probably have them all enabled, but there is a way you could just Google for a specific phone. Whoops, wrong one. Different phones will have, because they have different operating systems, they have different distributors. They're gonna have different locations for this, but the whole point is you're going to look at the developer options, and then you're going to enable USB debugging, if you could see that there, right there. And that will allow you to start loading phones and testing it. Yep.
Do we need actual Android phones, or can we use emulators on the computer?
Yes, so that's another good question. But so I was going to get into that when we installed everything, but yes, you could also use the emulators. And usually they'll when you first try to install an app, like let's say I disconnect my laptop. Now by default it will choose. I think I have the Pixel 2 installed here, and it has a full emulator for this. So you can actually see this is a full Pixel, and it's I could do the same functionality here. The reason why so it worked. The reason why I actually use this is because later on we're going to use sensors, and although you can emulate some functions like shaking the phone, or you could spin it and see what happens. You could click like the phone button, or sorry, this is a screenshot. You can zoom in. You can do a whole bunch of things with them. They're very, very powerful. You can interface them through command line, but a lot of times, it's hard to get some of the sensor values. So if you're playing around with sensors, which we're going to be doing in a bit, it's easier just to use a real phone. Yeah, so I'll close out this simulator. Yeah, so I was just really just showing you guys how some of this would look like, so put it in context. But we'll get to kind of the specifics of how to get set up and all that, and we'll walk you guys through it. So yeah, we went through views, and I already showed you an example XML file. This is a linear layout, and again, you can here you're going to be able to define a whole bunch of constants, strings, and so here, yes, here there's a lot of programming practices. Android Studio will bother you about this too, where it's saying that it should be any string that you put here should be defined in a file. So there's actually one of the things I kind of hovered over. There's a values file, the values folder here that has a strings XML file, and you could essentially define any strings. And this is, for good programming practice, if you have any constants, like any titles that you're using or something like that, and you want it to be changed, you don't. It's the equivalent of hard coding anything, right? So yeah. And same thing for colors and all that. You don't want to hard code these things. We're doing very simple baby apps right now, but for if you going to deploy these in the Google App Store, you want to keep this in mind. So yeah, this is we'll go briefly over material design, where it's a comprehensive guide for the visual motion and interaction design across these platforms. It started around Android 5.0, and it provides you with these design guidelines for the dimensions, layouts, fonts, and all that. And it came with a bunch of themes as well, and that you can use, and you could customize these style themes, and that makes it very easy if you're. The themes are actually pretty nice. So if you saw the app we just developed, they actually had a nice little bar at the top, and it just makes it. There's light and dark themes as well, but it just before when back in my day when we first started Android programming, it was just literally a white screen that had nothing on it. So it's nice to have these default themes and all that. And this is just an example of how some styles might be defined. And you could check out more at that link for the material design. So that was kind of activities and views. And another important component that, again, we'll have to briefly go through because we can't cover all of Android in one day, but this is the services. So services are just kind of like any asynchronous tasks that you need to run. So typically there's anything that doesn't really require any interaction with the user. I would say some example reasons why you might want to run a service is you don't want it to interrupt the GUI. For example, if you're trying to download a file from the internet, like an image, you might, instead of just freezing if you were to put those processes in the activity, any very long processes, it's gonna just freeze up the UI because it's just gonna be tied up in that. So you want to throw that to the background, and you could use what's called they have default progress bars. So whenever you're downloading something, you see a little spin wheel. So they have very nice API for that to kind of update those progress bars, and there's a whole class of progress bars you can use. And yeah, as I mentioned, they run on the main thread of the process, and you can use async task for it's an asynchronous task, so that they don't block the main thread. And there's three forms of services. There's the foreground, which performs any operation noticeable to the user. So, for example, I'm sure you guys use like Google Maps or you're playing a phone, you see a little notification. And the reason, these are kind of significant things that are interacting with the user. And in the background is the other type of app that you could, whenever you create a service, you kind of set these properties, whether it's a foreground, a background, or the bound service as well. We'll talk about that in a minute. But the background is essentially just constantly running in the background, and it doesn't really return a result to the user. It kind of just updates some data. And it continues running even when the user isn't interacting with the app. So this might be just something that you might be monitoring, but you might ask the question, okay, why don't we just make everything foreground? Or why would we choose a background or vice versa? So we'll get to it in a bit, but background services can get killed off if you have a lot of apps running, whereas foreground are always going to stay alive as long as they're running. The only issue is that they're going to be prominent, and you don't want your app to always have a notification. It's going to look like malware on your device. And then you have the bound services, which essentially only work when they bind to other components of a service. So they provide this kind of client service interface that allows components to interact with some particular service that they're providing, and they only run as long as the other application that's bound to it is running. And this is kind of the life cycle that you can see where generally for the background and foreground services, when you call start service, you have the onCreate just as an activity, and then you have onStart command, which typically will run a thread, and then you'll have a service running. So you guys have done threading before, right? I'm assuming, and then when the service is stopped by itself or a client, it will go to onDestroy, it might get killed by the system itself. And then bind service is similar, where you have on create, and then it says on bind, which is analogous to on start, and then it'll say the clients are bound to the service, and then whenever they unbind, they go to on destroy and all that. So they have a slightly different life cycle than the other services. And this is a skeleton. We're not going to be programming any services today. Just we don't have time. But this is just showing you that it says before you have the on create, and then here you would have a thread, a new thread, so you could call a run whenever the service is created, and then you could define it on destroy. This could be defined as a function, just like any other threading programming that you're doing, where instead of run, you call some function that might run whenever the service starts. And so so we went over activities, we went over services, and this is the other kind of big player here, is a big component of this application framework, is content providers and resources. So we kind of have dived a little bit into the resources side of things, using you've seen the R class that kind of maintains all those resources. But content providers, which we can't get into just because of time, they essentially store and retrieve data and make it accessible to all applications to make it persistent. So they allow you to manage and access a structured set of data. So normally, for those of you familiar with database management and all that, the most commonly used interface for this is the SQLite database. They have a really nice API where you can essentially develop SQL queries for any content that you're storing locally on your system for your particular application. And it essentially also externalizes the resources from the application code. And I would say, as I mentioned before, you have these resource classes that allow you to access your images, your strings, your layouts of all your XML files in kind of a structured way. And they're mapped by the SDK tools into an ID, which is kind of what we showed before, where you r.id. And yeah, this is a static class, and it can be used to get any resources. So yeah, this is a wall of text, but I'll try to go through this briefly to just discuss the inter-process communication between apps. So the main idea is intents, where they're kind of this high-level use of the binder inter-process communication. And it's essentially a way to pass messages between activities and services and broadcast receivers, which we'll talk about after this. And they contain this abstract description of what you're trying to do. To pass along data, so you can not only send an intent to start some activity, but you could also package it with some messages and information. And they allow for this late runtime binding between components in the same or different applications. And there's two types of intents. So the first is explicit, where you can really specify, okay, I really want a specific activity to launch. This is my intent. So when I start this intent, start this explicitly. And then there's the implicit ones, which there is no explicit target. You kind of say, I want some particular service, and this is what we'll get into in broadcast receivers, where it's kind of like if some of you are familiar with pub sub environments. It's kind of saying, okay, what services are available to me? I want this general service, like a camera service, and there might be multiple apps that implement it. And once an intent is issued, the Android system finds the appropriate activity or service that to respond to this intent. And as I mentioned, there might be multiple agents for this, and an intent filter is specified by an activity or service or broadcast receiver to inform them which implicit intents they can handle. And like I said, you can filter by a specific category, data type, or an action. So yeah, these are your broadcast receivers, and these will this is kind of to provide some of these services and enable, okay, if I have some camera app or some service that I'm providing, I'm going to want to provide a way to kind of broadcast what it is I'm providing. And so this is kind of the That's why I mentioned it's a system-wide pub subs mechanism, and you can broadcast the events at all time, and you can broadcast across all applications, and you could have local broadcasts within a process as well. And again, this is kind of some very specific details that you'll dive into whenever you eventually, if and when you develop a broadcast receiver, you're gonna see what the difference between global and local broadcasts are, depending on the security needs of your or what applications you want seeing the services that you have. And the receiver is essentially dormant code which gets activated once a particular intent subscribes to it. So you just have some code that's lying there, and whenever an intent comes, it will call whatever code you have. And a receiver can be registered either dynamically from the class instance or statically within the manifest file. So we will talk now in a bit about manifest files in terms of intents and all that. But oops, went too far. And then finally, you do have power management and wake locks. So as I mentioned, power management is designed to kind of enter or suspend the state, and it can forcibly stop processes from running to conserve power or memory in some cases. And there is a way of providing wake locks where you can prevent the system from killing it, so that if you're in a low power state, for example, if you go into low power mode and you want something running constantly, like some foreground service, or you can specify that these specific wake locks. So yeah, now I mean we've already made an Android app, but we'll probably go into some of we'll do more of a demo now. So if you guys want to get your did everyone, I mean, who here has their laptops to kind of develop some things? Okay. If you guys want, I have maybe what we can do is I could either pass out phones, or I guess we could probably use the emulator for at least initially. We're gonna eventually develop 2 apps, so maybe just for now you guys could use the emulator, and later on if we have time, or depending on how everyone's feeling, we could use actual phones if you want to test it or whatnot. I'll show you some functionality of how it works. So if you guys have that ready, you could open up Android Studio. Do you guys want a break, or need like a 5-minute break or anything? Yeah? Okay, 'cause I think we're at like an hour. Okay. I'll give you guys like a 5-minute break while you're setting up and all that.
With the demo, do we need to import anything or any setup specifically for it?
No, you
Not
can
really?
use do not import settings. Yeah,
Alright,
yeah,
just want to make sure.
it should be fine.
Okay. Now, are you gonna be a TA for this guy? I don't think
No,
it doesn't have TA, right?
I don't think it has a TA. No, I'm just like a guest lecturer. We do have like our lab comes up with like project ideas.
Uh-huh.
So I think what will happen is I'll probably throw a bunch of project ideas, and if people accept my project, I'll be their mentor for it.
Oh,
That's
cool.
about it. Yeah.
Okay. So you can send your email and stuff like
Yeah, of course. Yeah. And if you want to brainstorm about ideas too, I'd be happy to do that as well.
Oh, yeah. Sure.
You. Oh, sorry. I mean, I'm not sure how good it is. Oh, yeah, you can see. 我会像这种一样。真的是紫薇笔记，为什么要下？这下现在。
I know they have like Visual Studio.
I like the software that
I don't develop in
and stuff like that.
I know it's fairly straightforward. They do like Swift and all these other language, they have another language. It's fairly same module.
Yeah.
How did you do this? That
Yeah.
this up workshop before?
Yeah, so you have it Windows. Yeah, Windows is gonna be tough because
Oh,
you're gonna have to install ADB. So normally it should. Oh, did you actually enable the developer options? So
I'm not sure.
yeah, so if you go here, there should be developer options. Okay, so yeah, hold on. No. So I'll show you right now how to do it. So for the Pixel, you have to enable it. So that's a Pixel, right? Is this a Pixel or?
This is Redmi.
Okay.
Xiaomi.
So it should be about phone. It should be yeah, about phone, and then I think if you do Android version, oh no, not this one. It's either Android version or kernel version maybe. Yeah. So now this is engineering mode. No, that's engineering mode. Hold on, let me Google it. So it's one of these where you have to keep clicking. Build number. Okay. Yeah. So in the build number, where's the build number? There should be a build number somewhere. Is this it? Yeah. Okay. So now we set that up, Now you'll have developers options enabled. Should be. All right, maybe something isn't enabled yet. Yeah. So it should already be. If you go to settings again. There should be developer options.
Oh, the same thing? This thing
Yeah, here we go. So now you will enable USB debugging. Okay. And then you always allow from this computer. And now it should show up.
Oh yeah, I see.
There you go. Perfect.
Fine. Thanks a
All
lot.
right. Yeah. So there's a if you guys are working with Android phones or if you want, there's a whole process of enabling developer options. So you have to go to your settings, and different phones might have specific settings, but you essentially go to your settings, and then you go to about phone, and then there's a build number, and then you click on it 7 times, and then it enables the developer options. And then from there, you could enable your developer options. It's a very complicated process, but if anyone is using Android, I could help you out with that.
Will you guys lend us Android phones if we don't have Android phones?
Yeah, if you want to use
Not
it.
like that now, but like for our projects or something.
Oh yeah, of course. I mean, we have a whole bunch. Yeah, and we have tablets too. If you guys want to play around with tablets, yeah. So okay, maybe we'll start again. So yeah, if you guys have the Android Studio installed, these instructions kind of tell you everything you need to install. But actually, now when you install Android Studio, it takes care of a lot of these things for you, especially with the SDK manager and all that. The one issue is ADB. If you're on Windows, I think you'll have to install that differently if you want to do some debugging. But yeah, I think for the bare minimum for initially, you should be fine with just the base installation of Android Studio. And I'll see, we kind of have gone through this, like the file structure and all that. I'll try to discuss some components. So yeah, if you guys want to first test making a new, maybe the first thing we could do is just make a new app and then create an app and run it using the emulator environment, where you just create the app, the main activity, and then just run it and see if it opens up on the emulator. So if you guys want to do that initially, and you'll see one thing I'll go over, just to go over some of the components. So there's Gradle scripts, and they will kind of specify a lot of the dependencies of your system, such as these are automatically generated when you start configuring your system, but it's essentially what maintains like the SDK version, the minimum SDK version you need, as well as any other dependencies for what needs to be downloaded. And honestly, you don't really want to mess around with this file unless you absolutely have to. And you'll see when you're developing and going through all your Stack Overflow solutions that sometimes you have to, but a lot of times it automatically takes care of it for you. So, for example, if you're using a particular API that is a greater version than the minimum SDK, then when you try using that API, it will tell you, okay, you have an error in this code because of the version. Do you want to update this? And then when you update it, so for example, if I want to update this to 16, you can then sync, and it will kind of recompile your whole project and make sure that everything is consistent, and anything that that needs to be refactored is refactored and all that. So it's really, really nice environment for you kind of work with. It used to be much, much clunkier and uglier, but now it's actually become pretty robust. So yeah, if you guys want to go ahead and get that app going, has anyone not been able to do like a base app, or you guys like good to go, or it's okay to raise your hand if like you need some time, or I think everyone's okay. Did everyone get like the emulator running? Yeah. Okay. Cool. Yeah. So yeah, just diving into Gradle. Yeah. So it's an open source build system that's used by Android Studio, and the module level build is the one that is most related to your to your to your app, and that's the one that if you do have to download, if you do have to modify it, then you would want to modify that, and you could explore Gradle and all that more through that link. And this is ADB. This is what I was talking about before. This command line tool, and it allows you to communicate with either your emulator instance or your Android device. And there's a client that runs on your development machine, and the server runs as a background process on your development machine as well. And there's a daemon that runs on your device, your emulator device, that tries to communicate with it. And it's shipped with the development environment. So you should have it. It's just sometimes I've seen on Windows, especially older versions of Windows, sometimes it struggles to find the ADB. So these are some useful commands if you guys are into command lines. You could test it out if you have access to the file, where you could do ADB logcat, and you'll find logcat is going to be your best friend, especially if you look at you could actually see it in your Android Studio. You don't need ADB. There's a logcat here, and this is any logging that you do. There's a log API that you can use that says log.i, and it will essentially allow you to filter out messages. So verbose is just parse out all your logs, but you could do debug messages, or you could do info if you just want to provide some info, warnings, errors, all that, just like any other logging that you do. But this is a nice little API to kind of filter that out. And then devices that's going to save you a lot of headaches. So whenever you're playing around with the phone and you realize there's nothing's going on, why isn't it attaching? You could see here it will give you a lot of information on what's going on with your device. And I think one of the biggest, so if I go ADB devices, like I mentioned before, it says it here, but when you attach your phone, first, if you don't have developer options enabled and USB debugging, you're not going to see it. And second, if you do have those enabled, you'll see as soon as you plug it in, it'll ask you, do you want to trust this computer? And you have to do that unless you check the box and say, always trust this computer forever. It's going to ask you every time. And if you just exit out or you don't actually provide it access, it'll be you'll see a restriction on it, and that will cause you a headache. And so just for future reference when you're programming these things. And then you could also, whenever you generate an APK, which is actually APKs are the application packages that are generated whenever you want to deploy your device. It's kind of like the binary files that stores everything, that all the resources and everything you're using. Then you could do ADB install. So we use that a lot in our lab, because if I'm developing an app and I just want to ship something easy to somebody else that's that wants to use our app, then we could just push it instead of forcing them to compile it and all that. And shell allows you to start a remote shell in your device, because these are essentially running Linux operating systems. So you could also do a shell and navigate the file structure within the device. And then pull push can pull and push files to and from the device, which is nice whenever especially in some of these research projects that you're doing. You're going to be generating some CSV files or some sensor measurements and all that. So it's a very easy way to just pull all devices instead of having to email it to yourself or whatever. yeah, you could, as I mentioned, you can monitor the ADB monitor embedded in Android and Studio can uh, it's very very convenient, and you could look at that link to explore all the functionalities of it, or look at the man page if you want to do that. And we'll briefly go over the permission framework. It's obviously evolved a lot since the beginning, but it's essentially a way uh, to uh, to manage how how particular apps can access different types of sensors. So, for example, you could have by default an app's not going to have access to any of these sensors. So if you wanted to use location or the camera or the microphone or even the internet, you would have to request that permission, and then that's when as a user you'll see, okay, do you want to allow this device to use this permission? Um, so, and then they have these. So Android 5.1 had these install time permission checks where developers would declare these permissions, and the user would accept the permission or not. And if they accepted it, then that app would have permission for the entire duration of that it was installed on the app. And whereas in Android 6 you had runtime permission checks where they would request each permission separately in code, and the user can allow or deny each permission and can revoke it as well. Okay, so with that, we'll probably try to do some demos very quickly. I'll try to walk you through them. So in the first demo, we're going to actually see how we can access the accelerometer, and then to do crash detection. So if I want to just detect that I'm moving, well, the first step will be just to see the device moving and see those values, and then I want to see if it crashes into the object. And the intuition there is that I should have a sharp change in the acceleration if I see that. And then finally, I just also want you guys to kind of see how you can interface with another sensor like the camera app and then take values from that sensor. So we can go ahead and start with the first one. I think when you're doing these projects and you want to access the sensors, I would say this motion, you could go to use Google, Android sensor API, and they have this sensors overview, and it will give you a very, very good overview of the structure of all the sensors, and in particular the motion sensors, position sensors. For the most part, it's a lot of the inertial movement sensors or GPS, but you could also see how you can look at the camera and all these APIs. And for the most part, you're most likely going to be, you're most likely going to be, Googling it whenever you want to use a particular camera or a particular sensor and all that. So I can show you, for example. We could show, let's see, what is this? If I'm just going to show you guys another very brief example. You don't have to code this, but I want to show you. No, it's not this one. Okay, so we have this app here. This is, for example, how you would call an intent. So this should be. Okay, this is actually the second activity. So this is the main activity. So this is an idea of how, if you guys want to have multiple activities, it's not going to be really part of the demo. So this is just an example of how you would navigate between different activities. So if you have like your main interface and then you want to go to the second page that might have like your sensors and all that. So here in my main activity, I'll have this layout. Activity main, and it would have some buttons, and I might add, if you could see it. So here we have this text view that says "Welcome to Android Development," and then I added an edit box, and you can navigate the different views here. These are some common ones: switches, buttons, image views, text views, all that. So this is an edit text, and this is a button. So what I can do then is, if I wanted to have a second activity, I would essentially, you could create a new file. You could create, I think, a new layout resource file here, and I could call it whatever I want. So activity, you know, second page, and this could be, the source set will be, you know, where it's coming from. So you typically, it's because we're just calling this from the main, we could put wherever we want. And you know, we could by default set a linear layout, but you could later on you could look into what the different layouts that you have. But then we could generate this new content view here. That's kind of empty for now. And then from the main activity, you would have to create a second activity here. Like we could, for example, if I wanted to create a new activity, you'd go to new and you could say, okay, create activity. There's you could have Java classes, you could create whatever you want, but here we're going for the activity, and here I would want just probably an empty activity here, and I could call this, you know, second activity example. Actually, when you generate when you actually generate an activity, it generates. You could have this option of generating this layout, so I'll probably just do that, and I could delete the one I had here. So this is a second example, and it's going to set this content view automatically here. Now, if I wanted to call this new activity, second activity, I could use that button here, just like we did before, where I find if this button that we had defined here is called button continue, then in the main activity I would find it. Yeah, so button continue here, and you can set the on-click listener, and it's going to set the text to move to another screen. But then there's an API, the intent API that we discussed, like how to call other activities. And this is an example of an explicit activity where instead of the implicit, where I'm trying to look for a particular service, I'm looking explicitly for this second activity class. In this case, I'm going to change it to the one we just created, second activity example. And we won't worry about this now, but this intent.putExtra is essentially how you would put some values or extra values into. It's essentially like the message exchange between activities. So in this case here, and then you'd call start activity from this point with the intent that you created. So the intent that we create actually takes in two parameters, at least for this particular instance, where you pass it this activity context, and then with main activity.this, and then the second activity example class that we're looking for. So if I run this now, you should be able to. Let me look at the. So this is going to be running. It's building right now. It takes some time. Okay. So now, if you guys can see it, if I press continue, it's going to go to the second activity, which is blank for now. But I could add a whole bunch of things. And if we want to, we could also put, for example, if I wanted to take if I press back and I wanted to take whatever I typed in here, I could essentially get this edit text that I created using the find view ID, and we just called it edit text, and I could essentially say, okay, intent.putExtra, and this is just some extra username, which is just a fixed string, and so that's kind of like the variable name that we're doing, and then we could call etname.getText.toString. So that's essentially a way of grabbing the text from that view. So, and a lot of times you'll see that there's some intuitive ways of kind of seeing this. If you have this edit text, I could just do .getText, and then it won't be because it takes a specific string. You just have to make sure that it converts to strings. So this is an example of how we would pass messages between intents, and then you could. So I actually have an example here of how we would do that. So there is when you call onCreate, there's a way of getting. You could use this function called getIntent to get the intent that called your activity, and then you could actually call intent.getStringExtra. So anything that was passed to you, you could get string extra, and it's going to be there's going to be a key associated with it where we stored that we defined in the previous intent in the previous activity, and then we're just going to set the text to whatever message that is. So here, if I call instead a second activity, and I'm going to share a lot of this code with you, so you don't have to worry too much about it, but I'm just showing you how you can pass messages between one activity to the next. So here, if we run it, so yeah, this is, if I could change it to whatever I want here, name, so I put Lewis, and I put continue, it will show welcome Lewis here. It's just editing this value here. So that's an example of just passing text. Now, going back to the original goal of what we're looking at is we want to provide a way of accessing the sensor values. So you can actually take Google, the motion sensors API here, like I mentioned before, and this kind of tells you, it gives you a very good overview of the types of sensors that we're working with. So are you guys familiar with inertial measurement units, IMU? So it essentially consists of the accelerometer to measure your acceleration in the XYZ plane, and then it also consists of a gyroscope, which measures your roll, pitch, and yaw. Did the hand gesture wrong, but and then the magnetometer will measure your orientation very roughly, and it's not very reliable, but it is used to do this orientation. And one thing I'll say is that to use the gravity sensor or any of these sensors, you're going to have to use a sensor manager. So this is going to be a class that you have to import, and then you have a particular sensor, and you will essentially have to register the sensor. So for example, if we wanted to use, I should say that one nice thing and the reason why I keep pointing you guys to this API is that you really don't want to work with the raw data. It's nice sometimes to collect the raw data because later on you could then manipulate it however you want. But if you're trying to get some high-level inferencing about, for example, the linear acceleration, they provide these kind of inferred sensing values for you. So for instance, here you could do a gravity sensor, or you could do linear accelerometer instead of having to use the raw values coming out of those very noisy sensor measurements. And there's even, I think it's somewhere here, but there's for example, a step counter. They already have that API for you instead of that's very annoying logic that you have to write. And I would trust the Google developers much more than I would developing a step counter. So step detector, and then yes, if you want to work with raw data, this is how you would do it. So for example, if I wanted to get the accelerometer data immediately, then and they kind of explain too how you can do some of these calculations. But yeah, so essentially once you register your sensor manager, you would have to also develop this on sensor change, and you're going to get a sensor event. So depending, you typically if you register multiple sensors, they're all going to use the same on sensor change, and there is a way in the API to kind of filter out or see what sensor is sending that event. So if I was using, for example, both the accelerometer, the gyroscope, and the magnetometer, I'd have to say, okay, whenever there's an on sensor change, I have to check which sensor is sending this value. But for example, here we're just looking at the accelerometer, and here's just a way of kind of calculating gravity using the accelerometer. So you would access the event values. You're going to have this little event here, and it says event.value 0. That's going to be your x value, and this event.value 1 is your y value, and this is going to be your z. And you could also calculate the linear acceleration, which is already provided for you. So again, looking at this API, you could actually see, like, if you have this, depending on what sensor you specify, you could look at the type accelerometer, and you'll see what the sensor event data is here. So this is, it will tell you the units of measurement, the acceleration force along the x-axis, acceleration force along the y-axis, and acceleration force along the z-axis. So I think for the sake of time, actually, I think we're running short. I'll probably just try to demo it for you how this would look like, and I think we will share the code with you and all that. So if we go to the accelerometer, it's okay. This is okay. It's right here. This is not it. Have it open somewhere here. Okay, here we go. So here you could see I get my sensor manager, like I said before, and you guys can see that okay, or let me see if I can zoom a bit. So here I'm just getting my sensor manager, and then I'm getting, for this case, we're just going to be detecting a crash. So we're just going to be getting the accelerometer. We don't need to get the roll pitch out. We just want to measure, like, okay, there should be a big shift in acceleration whenever I hit a crash. And then I'm going to get the default sensor for that. And this is an example of just, it's getting the default sensor for type accelerator. And then here, I could, in my layout, I defined three text views. So these are the text views for X, Y, and Z. I'm just going to have 3 text views there. And then I'm going to have a button that essentially starts recording. So whenever I click that button, it's going to register the listener. So you can the sensors are always going to be running, but you want to register a listener that says, okay, whenever the sensors change, or whenever the default accelerometer changes, we're going to call this on sensor change. So it would take in this second activity, this acceleration sensor that you got here from your sensor manager, and then here is the delay. So if you want to specify the frequency at which you're sampling a particular accelerometer, I think delay I just went these, but they have. You could look at the API and you could see, okay, what's good for different types of movements that I'm trying to do. And from here, you could see, okay, when in a sensor change, I'm going to set the text to XYZ. So I could actually just show you guys that really quick. I already have it enabled here. So if I show you, when I press the button, it's going to start record. Oh, I don't know why that last guy's not working, but yeah, it should be. Oh, yeah. So it should be. Whoops. All right. So this should be Z. So that was just a copy and paste error. So now if I rerun the app, so that's why I was only updating 2 of those values there. so let me show you this again. We're going to continue. If I press the button, okay, we're going to get all these. Now, what do I do with these values now? I'm going to get the normalized value across them. So, I mean, you could look at the equations, but essentially I'm taking the square root of the sum of all these values. And I will essentially see if the magnitude is greater than 15. And if it's greater than 15, then I will essentially, here I'm creating a media player that will create this, that's going to play a crash file. So this is actually an MP3 file that you could put in the raw. So anytime you have like a media file that you want to put, like a video or an audio file, you'll typically put it in the raw resource folder. So now if I go back here, I'm going to be doing this, and then okay, yeah. So if I hit crash, okay, yeah, it's somewhat working, right? It's a little bit delayed. So that's an example of, just accessing those sensors. You guys will have this code. You could play around with that, and you could look at the gyroscope and magnetometer too if you want to play around with those. And then the last thing I'll show you guys is an example of implicit intent, where we have a main activity here, and we want to actually access the camera. So what I did was we have this layout that has a couple of views in it. It's just going to have a button that's going to be take photo, and then you're going to have an image view. So this is actually it's just another class where you can load images into it, just like any API, and we could put whatever we want in there. So then what I could do is go back to my main activity, and I could set, okay, I have image view here, find view by ID, r.image view. I have my button, and for this set on click listener, I'm actually just going to create an intent just as before, and you're going to see that it's going to force you to put it in a try catch clause to catch any exceptions. If you're not familiar with Java, Android Studio will tell you that you need to do that. And here we're setting an implicit intent where we're saying, okay, I want to actually this. So this is a MediaStore.action.image capture. So we're just creating this camera intent, and then we're going to create a camera request. So and this is different than before, because now, before we just called start activity and we kind of just said, okay, call second activity and let it do whatever it wants. But here, because we're calling it camera, we wanted to take a picture and return a result that we could put in our image view. So there's a way of saying, okay, start activity for result, and then when you would then have to create this on activity result. So anytime you get a result from the activity returns, you would get you could specify a request code, a result code, and the data that it's passing you. So again, remember that apps use the intents to pass data across each other. So here we're just checking to see if the request code is the camera request that we put up here. So we have this specific camera request that we defined up here, and then here we also want to make sure that the result's okay. So it's just a result that we get, and then when we get the data, we would essentially create a bitmap. So there's different formats you can use, and then you set the image. So I will run this really quickly. Should be running. Okay, and yeah, so then you can just take the photo, and it'll call a camera. So obviously I didn't do this, so I'm gonna take a picture of myself, a nice little selfie, and then you see it there. So you guys will have the code for all this. You can play around with it, change it, do what you want. And if you have any questions, just let me know. And yeah, it also, again, I kind of threw a lot of ideas out here. We're gonna give you guys a lot of ideas for these projects. Yep.
If we're using emulators, I'm guessing you don't have access to sensors or cameras.
So there are. I'm pretty sure there's a way where you can use like the camera of your computer. There's a way to rig it. Yeah, it's gonna be a little bit trickier though, and you could emulate like shaking. Especially, I know Corona SDK, which is the one that uses that you could deploy both Android and iOS. I know that one has like shaking capabilities. But yeah, generally, if you want to work with those sensors, it's best to use it on the phones you're actually going to use.